Hey everyone, Adam Simmons here from Dgtl Infra, short for digital infrastructure. Hyperscale data centers are booming, and 2020 is tracking to be a record year for this segment of the industry, with demand extending worldwide, no matter if it is the United States, Europe, or Asia Pacific. In this video, I'm going to give you a quick overview of how hyperscale data centers fit into the broader data center landscape, why Amazon Web Services, Microsoft Azure, Facebook, and ByteDance, which is the owner of TikTok, are propelling the industry's growth, and what the digital infrastructure need is to support this growth. You might actually be able to begin investing in the hyperscale theme yourself, whether it is through buying assets or investing in publicly traded digital infrastructure stocks that are tied closely to hyperscale trends. So stay tuned, and I'll break this all down for you. Before I do, be sure to subscribe to the DgTl Infra channel and turn on the notifications so you don't miss my next in-depth video that is coming out soon. Now, let's jump into the video. So in this video, we're focusing on the hyperscale segment of the data center space. But first, it's important to frame out where hyperscale data centers fit into the entire data center landscape. You'll see the hyperscale category signified by the pink box on this page. And let's first quickly recap what we spoke about in the DataBank and zColo video, which was titled Big New Data Center M&A, What Does It Mean for 5G? And I'll provide you some quick background on each of the key data center segments, which we also touched on in that video. So on the left side of the page, we have retail data centers. And these facilities are run by third-party organizations that are multi-tenant accessible, meaning that multiple businesses of any size or industry may house their equipment within the data center. So companies of all types and sizes, from small and medium-sized businesses to Fortune 500 firms, use retail data centers. In retail, customers have smaller power requirements and require help to manage their equipment that reside in those data centers. Within retail, you have two subsegments. One is interconnection, where the customers are typically digital media providers such as Akamai, Netflix, and Hulu, and financial companies like Dow Jones and the Chicago Mercantile Exchange, or CME. On the enterprise side, your customers are typically large corporate enterprises like Exxon, Gap, Walmart, and United Health. So now really the focus is on the right side of the page, which are wholesale data centers. And wholesale data centers broadly provide space, power, and cooling to run large-scale computing or storage deployments. The tenants here are large internet and cloud companies that own and operate their network equipment. Space and power in these facilities are leased in larger capacities than in retail data centers, and as such, typically house fewer customers per facility. So the concept is similar to leasing a warehouse or office space in which the landlord provides facility maintenance to the tenant. Now moving to the subcategories of wholesale, you have what is also called wholesale, which are essentially facilities that provide private suites and large cages for tenants. And then moving to the middle of the wholesale section, which is the main focus of this series, which is hyperscale. And in hyperscale, the data center is typically leased by one customer or tenant per data center facility. And customers here are generally cloud providers or large enterprises seeking to exit their older enterprise facilities and outsource infrastructure needs. The customers for hyperscale facilities can typically be divided into three different categories. You have cloud service providers like Amazon Web Services, Microsoft Azure, and Google Cloud. You have internet companies like Facebook, Uber, Twitter, Netflix, Apple, and Salesforce. And you have emerging technology companies like Dropbox, Spotify, and Snapchat. So if we just step back and look from a high level, how hyperscale compares to some of the other facilities and what the pros and cons are for hyperscale facilities. So first on the pros side, you have high market growth during high IT spend cycles, and it's indexed to hyperscale capital expenditures, which we'll touch on later in this series. And that hyperscale capital expenditure growth is almost double retail colocation growth rates over the next 5-year period. Hyperscale facilities have long lease maturities and significant repeat business. And so if you think of yourself as a company that is a hyperscale business, the fact that you have longer leases can lead to securing better cost of debt terms. So for example, Digital Realty spends a lot of their focus on the hyperscale side and has one of the lowest costs of debt in the industry. And the lower cost of debt is really derived from having an investment grade credit rating, which hyperscale facilities also have. Some of the negatives for the hyperscale side are the customers have sizable bargaining power, given there's very few of them, particularly during renewal processes. And this can make the returns on invested capital lower than on the retail side of the data center space. Typically, your return on invested capital for hyperscale facilities is in the 9 to 11% range, and that has actually been trending down over the past few years. Hyperscale facilities can often be characterized as being commoditized businesses and sensitive to power rates in the market that they're in. So they tend to gravitate towards markets which offer power at very low costs. And then the customer concentration point again, where you have only a small number of target customers to achieve this high growth rate. And then finally, the risk of technology obsolescence is quite large in the hyperscale side, particularly when the long-term lease ends from the initial tenant. And so moving furthest to the right on the page, you have build-to-suit, also known as BTS. And this is where a company rents out an entire facility for its own dedicated use. The facilities offer more control over design space than a standard facility, but still require a large commitment in terms of energy use and overall expenses. So in the broader landscape of digital infrastructure, we're focusing on the data centers, which are on the left side of this page. And then within that data center segment, specifically the hyperscale subsegment. And then in addition to the actual facilities themselves, we're focusing on the customers of those hyperscale facilities, which we'll refer to as hyperscale customers. And those are your Amazon Web Services, Google Cloud, and Microsoft Azure. So one of the largest single trends that is reshaping the data center industry is the movement of computing resources and workloads to what is known as the cloud. And it's specifically to public cloud providers like Amazon Web Services or AWS, Microsoft Azure, Google Cloud, and the Chinese players as well, Alibaba and Tencent. And adoption of public cloud services is really being driven by economic decisions for a number of different workloads based on things like cost, speed, ease of use, ubiquity, and scalability, all of which the public cloud offers. And so the cloud service providers are placing their on-ramps to their services in what are called existing network nodes and architecting their networks and what are known as compute or storage nodes around these on-ramps. And so these on-ramps are being placed in facilities owned by the largest data center providers, including Equinix, CoreSite, and Digital Realty, particularly as they have a focus on interconnection. Let me now explain that broad summary in greater detail with a case study using Amazon Web Services. So we will use Amazon Web Services as a case study, given it's the largest public cloud service provider, and it will provide a case study for how its on-ramps, its network nodes, and compute or storage nodes are being architected so that we can better understand why public cloud service providers are using hyperscale data center facilities. So on this page, we have a depiction of what Amazon calls its different regions across the United States and Western Europe. The dotted lines signify Amazon's private network of dark fiber or wavelengths, which connect the different regions together. So Amazon Web Services operates in a series of regions and currently has 24 geographic regions and 77 of what are known as availability zones. And both these regions and availability zones are distributed worldwide. So for example, in the United States, Amazon Web Services has regions in Northern Virginia, Ohio, Northern California, and Oregon. In Europe, Amazon Web Services has regions in London, Paris, Frankfurt, Ireland, and Stockholm. In Asia, Amazon Web Services has regions in Tokyo, Japan, Osaka, Japan, Seoul, South Korea, Singapore, Hong Kong, Sydney, Australia, Mumbai, India, and Beijing in China. And finally, in South America, Amazon Web Services has a region in Sao Paulo, Brazil. So each of these Amazon Web Services regions is connected to Amazon's private network, as you can see by the dotted lines on this page. And this consists of dark fiber, or wavelengths leased from the largest fiber providers like Zayo and Lumen Technologies, which, as a side note, DgTL Infra also covers and have written extensively about on our website, dgtlinfra.com. In addition to its regions, Amazon Web Services has a larger number of edge locations where end users access services located at Amazon Web Services, such as Content Delivery Network, known as CDN, Domain Name System, or DNS, Distributed Denial of Service, referred to as DDoS, and Firewall. So with that framework of an Amazon Web Services region in mind, let's try to visually depict how the different components of this region architecture fit in with the broader ecosystem, which includes availability zones, data centers, and transit centers, as you see on this page. So just to frame it out, this page really shows what a region is from a broad sense. The dotted pink box that goes around most of the diagram is in fact the region. Availability zones are comprised of one or more data centers that house Amazon Web Services equipment, and no single data center is included in more than one availability zone. Therefore, you see on the page that some availability zones, represented by the light purple dash boxes, have one data center, others have two data centers, and others have three data centers within the availability zone. Also, each Amazon Web Services region has at least two availability zones. In this example, the region has 4 availability zones shown. Availability zones are basically isolated locations within a region, meaning that if one availability zone fails, the other availability zones will remain unaffected. For example, each availability zone is in a different floodplain and powered by a different electrical substation in order to ensure that it does not affect other availability zones. Even with these precautions in place, customers of Amazon Web Services often do place their resources in multiple availability zones within a region to avoid downtime should one availability zone fail or experience an issue. The data centers within each availability zone are all connected to one another by fiber and are typically close enough to ensure latency of less than 1 millisecond. The data centers here are depicted as the dark blue boxes on this page, and each data center has a dark blue line connecting to one another, which are referred to as intra-availability zone connections. Each availability zone is then connected to all the other availability zones within the region via fiber, with latency of less than 2 milliseconds. This is depicted as the pink lines on the page and referred to as inter-availability zone connections. Further, each availability zone within the region is also linked via fiber to what Amazon refers to as transit centers, and these are signified by the triangles with dark purple borders. Transit centers are network-rich third-party data centers that are operated by companies like Equinix and CoreSite, and they can also be thought of as interconnection-focused data centers. These transit centers are where the physical connections exist so that traffic to and from data centers in the availability zones can leave Amazon Web Services network, signified by the lines connecting to number 1 through number 4. When this traffic leaves an availability zone via a transit center, it can travel to a number of different locations, which we signify on this page as numbers 1 through 4. So number 1 is an example of traffic leaving via the Amazon private network to other regions. Number 2 is to direct connect customers. And direct connect is when an enterprise has private connectivity between Amazon Web Services and their data center, office, or colocation environment. Number 3 is an example of traffic leaving for the internet via a transit or peering relationship. And finally, number 4 is an example of traffic leaving to a customer sourcing services via a cloud exchange. Cloud exchanges are offered by companies like Equinix or CoreSite, and a cloud exchange in the Equinix example is where a third-party data center provider like Equinix provides direct and private connectivity between two participants within the Equinix footprint. Typically, this is between a buyer, such as an enterprise co-located in Equinix facilities, and a seller, such as a cloud provider. So focusing on the transit centers, Amazon Web Services and other cloud service providers have deployments in transit centers, which are referred to as on-ramps. And these can really be visualized in a similar manner to the ramps used to get on or off of a major highway. So in summary, different types of data centers serve different roles within the architecture of a hyperscale customer like Amazon Web Services. Large footprint hyperscale data centers within availability zones, depicted as the dark blue boxes on the page, are needed to house scaled deployments of servers and other equipment. These hyperscale facilities may be situated in less expensive locations in terms of land, power, and taxes, and are often referred to as compute or storage nodes. And so hyperscale customers like Amazon Web Services, Microsoft, and Google Cloud typically lease space on a wholesale basis or build their own data centers to meet these compute or storage requirements. Companies like Digital Realty, CyrusOne, and QTS typically serve as the compute or storage nodes, which represent the hyperscale facilities. And finally, smaller deployments are needed in connectivity-rich locations so that different regions can send traffic among one another within a cloud platform or as a location to distribute services externally to customers through private connections or via the internet, often referred to as network nodes. So hyperscale companies like Amazon Web Services also use these interconnection-oriented facilities to serve their network requirements. And these network nodes are really controlled by firms like Equinix, CoreSite, and Digital Realty. So now with that background about how a hyperscale customer like Amazon Web Services really fits in with the broader data center ecosystem, let's now focus on the tremendous growth that these hyperscale customers have been experiencing, because there's a tremendous amount of them who are growing their revenues and investing in their business at an incredibly fast growth pace. So hyperscale customer revenues are continuing to grow strongly, which is driving them to ramp up their investments in cloud infrastructure by growing their capital expenditures significantly, as seen on this page. So on this page, total capital expenditures and, where available, cloud capital expenditures from 2015 are compared to estimates for the full year 2020 by company. So overall, for the 15 hyperscale customers shown, the total capital expenditures from 2015 of $52 billion is expected to grow to $131 billion for the whole of 2020, which represents a staggering compound annual growth rate of 20%. These hyperscale customers include Google, Amazon, Microsoft, Facebook, Apple, Alibaba, Tencent, IBM, Oracle, Baidu, SAP, Cisco, Salesforce, eBay, and Twitter. And as you can see, related to the case study we just walked through for Amazon Web Services, that company is clearly a leader in the absolute amount of capital expenditures it is making to grow its business, alongside Google and Microsoft as the top 3 hyperscale customers. So hyperscale capital expenditures are an important indicator to focus on because it is considered a leading indicator for the multi-tenant data center industry, largely because 50% of all data center space, power, cooling, and interconnection is outsourced to third-party data centers rather than built and maintained by the hyperscale customers themselves, which is known as insourcing. The percentage of outsourcing is expected to begin increasing to the 60% range by 2022, which is largely driven by the vast scale that the multi-tenant data center operators like Equinix and Digital Realty have gained. Outsourcing will drive even more business to multi-tenant data centers like Equinix and Digital Realty, and especially wholesale providers that have specialized in large-scale data center developments across top-tier markets. As an example, across Tier 1 European markets like London, Paris, Frankfurt, and Amsterdam, hyperscale customers are outsourcing almost 100% of their capacity needs, given that these hyperscale companies tend to be headquartered in either the United States or China. So as discussed previously, hyperscale companies like Amazon Web Services, Microsoft, and Google Cloud typically lease space on a wholesale basis or they build their own data centers to meet these compute or storage requirements. So this brings us to the right side of the page, where certain hyperscale customers have a greater propensity to lease facilities versus building facilities themselves. The dark blue arrow signifies the recent trend directionally for where these hyperscale customers are trending in the lease versus build decision. So if we look at the build versus lease chart, increasingly companies are looking to outsource, meaning lease, their infrastructure. And this is driven primarily by 4 points, which are speed to market requirements, scarcity of land and power, complexity in construction, and capital allocation decisions where they're turning capital expenditures into operating expenditures. Let's use a couple companies as examples to talk in a bit more detail. So Amazon at 35% build, followed by Google at 30% build, and then Microsoft at 20% build, are pursuing some modest self-builds of their data centers instead of leasing all of their capacity needs from third-party facilities. Whereas companies like Alibaba, Tencent, Oracle, IBM, SAP, and Salesforce perform relatively almost no self-build and thus have the greatest estimated leasing mix. Directionally, we can see Google is trending towards a greater propensity to lease, while Amazon and Microsoft are trending towards a greater propensity to build facilities. So finally, it's worth touching on the actual hyperscale customer deployments and their general leasing patterns over the past couple of years. So this map depicts the locations of the hyperscale customers with specific callouts on the bottom left side of the page for Amazon Web Services, Facebook, Google Cloud, and Microsoft Azure. These labels signify their dedicated facilities throughout the world, demonstrating that the key markets, referred to as Tier 1 markets, are all part of the hyperscale customer deployment plan. So in the United States, those Tier 1 markets are Northern Virginia, Silicon Valley, Dallas, Chicago, Phoenix, New York, and Atlanta, which are all well covered by the hyperscale customers. In Europe, what are known as the FLAP markets, Frankfurt, London, Amsterdam, and Paris, are all Tier 1 markets. And in addition, Dublin is also a key market, and all 5 of those markets are well covered by the hyperscale customers as well. So let's run through a quick example of a specific market to give you a better sense of the dynamics involved in hyperscale leasing. So let's take the example of Northern Virginia, which is the largest data center market in the United States in terms of supply at about 1,200 megawatts. Capacity under construction in Northern Virginia is more than 700 megawatts, and Northern Virginia is also the largest market in terms of annual leasing volume, which for the first 9 months of 2020 has been 330 megawatts, a sharp increase from 125 megawatts of leasing volume in 2019, and about 295 megawatts of leasing volume in 2018. So even in the first 9 months of 2020, it has already exceeded both 2019 and 2018's leasing volume. So the leasing volume is comprised of all of those hyperscale customers that we talked about on the previous page. And really, just to give you a sense, it's quite a lumpy leasing environment, so it does change year to year who is leasing the most capacity. But let's review a few historical years just to get a sense of who comprised the majority of leasing volume. So in 2016, Microsoft and Oracle drove record leasing volumes in Northern Virginia, comprising about 70% of total leasing. In 2017, it was Facebook and Apple that were the 2 largest customers, consisting of about 40% of total leasing. In 2018, another record leasing year was set, with Microsoft and Facebook collectively leasing about 65% of capacity. In 2019, leasing was much lighter in Northern Virginia than in prior years, and the customer base was much more diversified across a smaller group of transactions, with the 2 largest customers being Alibaba and Uber, comprising only about 20% of leasing. And then finally, during the first 9 months of 2020, it was Microsoft, ByteDance, which is the owner of TikTok, and then Facebook, all accounted for about 75% of leasing during those first 9 months. So hopefully you found this video helpful. If you did, then please share it with somebody you think might also find it helpful. Consider subscribing to DgTL Infra and visit us at dgtlinfra.com for more of the latest news on digital infrastructure. Thank you for watching this video. Be sure to like the video and post in the comments telling me whether you think that the hyperscale customers like Amazon, Microsoft, and Google can continue their incredible rate of growth going forward. Thanks again for watching, and I will see you in the next video.